Hey, I'm Don, and I'm going to show you how to use a new navigation library called Jetpack Navigation 3. So let's start with the basics. In Nav3, every piece of content that you can navigate to is represented by a key. This is created by you, it can be any type, and it's usually a simple data class. For content that doesn't have arguments, you can use an object. For example, let's say you're working at Google and you're building a chat app. Not that hard to imagine, right? You might have a data object key that's used to represent a screen showing a list of chats. And you might have a data class to represent the chat detail screen with an ID for the chat ID. To be clear, you can use any type for your keys, but Nav3 does provide an optional marker interface called navKey. This makes it easy to retain your keys through config changes and process death. You just need to ensure that your keys are serializable. So to navigate, you add these keys to a list known as the backstack. You own the backstack, but the type must be a list backed by composed state, so that Nav3 can observe any changes to that list. If you're using the navKey interface for your keys, you can use the remember nav backstack helper function to create your backstack, and this will retain your backstack through config changes and process death. Usually, it's the topmost key whose content is currently visible. So in our example, we might start with the chat list as the starting key, and then navigate to the chat detail screen by adding that key to the backstack. And to go back, you just remove the last element from the backstack. So navigating really is as simple as adding and removing items from a list. So how do we actually define this content to display? And how does Nav3 display that content? Well, you start by defining composable content in a class called NavEntry. This holds the content for a given key. So to resolve a key to a NavEntry, you define something called an entryProvider. This is just a function that takes a key and returns the NavEntry for that key. So in our code example here, we just check to see whether the key is a chat list, and then create a NavEntry using that key with the composable content for that screen. So the last piece of this puzzle is the UI component which displays the content, and this is called navDisplay. This observes the backstack and uses the entryProvider to obtain the content for the key to display. By default, it will just display the content for the last key in the backstack. In terms of ownership, you own everything except the navDisplay. The only difference is the types. The key can be any type, the content and backstack are composed types, and the entryProvider is a Nav3 type. So, to demonstrate all this, I'm going to build the app I just talked about. We'll have two screens, one for the list of chats, and one showing the chat detail. Pretty standard stuff. Okay, so let's switch to Android Studio, and we're going to start by defining our keys. So we'll have a data object for the chat list screen, and we'll use a data class for the chat detail screen. And we'll have an ID field for the chat ID. Now we've defined our keys, we can define our backstack. And we're going to remember this between compositions and create it using mutable state list of. And we're going to give it the type of the keys. And in our case, it's just any type, although we could use the nav key type here. And we're going to give it a starting key. So this is going to be the first screen that our users see in the app. Now we can create our nav display. This takes a backstack, which is what it's going to observe. And it also has a built-in back handler. And this is specified using the onBack parameter. It's a lambda that will be executed when the back operation completes. So in our case, we're just going to remove the last item from the backstack. Lastly, we need to provide this entryProvider. And this is a lambda that gives us a key that we need to convert into a NavEntry. So all we'll do here is check the type of the key. So when it is a chat list, we're going to create a nav entry with the key and then specify the content for the chat list screen. So I already have this content, and this has an event lambda called onChatClicked. That's going to give us the ID of the item in the list which was just clicked. And at this point, we just need to create the key for the chat detail screen and add it to our backstack. So we can do this in a single operation by adding a chat detail, specifying the ID when we create it, to the backstack. So we can do the same thing here for the chat detail screen. So we'll just change the type here, and we've got different content for the chat detail screen. Now this expects the ID of the chat, and we can obtain that from the key itself. So we know that this key is of type chat detail. We specified that it has an ID field, so we can just do key ID. So there's a lot of red lines here, and that's because this is an exhaustive when statement. So it's expecting an else branch. So for this, we'll just do error unknown key. Okay, so that should be everything we need. So let's run the app and see if it actually works. So here we have our chat list. And if we tap on one of these chats, we're going to see the details of that chat. One of the really nice things about NavEntry is you get animations out of the box. So when we go back, you'll see that the outgoing screen scales down, and we even get predictive back animation that allows us to peek to the screen behind. So, yay, we can navigate between two screens inside a single app module. But your app is likely more complex than that, with multiple modules, or at least a better separation of concerns than having all your navigation code lumped into a single activity. Luckily, we've actually thought about how you can use NavEntry in a more modularized environment. So as I showed before, the entry provider is responsible for returning the nav entry associated with a given key. That's why we call it an entry provider. And using a when statement is okay if you're just creating a quick prototype or a demo, but if you look at the code, you can see that there's a few repetitive tasks in here. We have to check the key type each time, and we always create a nav entry with that same key. And we always need an else branch. This feels like boilerplate, which is why we created an entry provider DSL. To use this, you can call entry provider, and the trailing lambda is our DSL builder. For those of you familiar with Navigation 2, this is kind of like how the DSL works for defining your nav graph inside a nav host. Now, instead of creating nav entry objects directly, you can just use entry. This takes the key type as a parameter, and the trailing lambda is the composable content for that key. The key object is passed as a lambda parameter, so we can obtain any extra data from it, such as navigation arguments. This structure comes in really handy for splitting up your entry provider, which is useful when you have different teams managing different screens and features. Instead of calling entry directly inside the entry provider builder, you can extract each one into its own extension function on the entry provider scope provided by the DSL. And we can move those extension functions into separate modules. You don't have to do it this way. This is really just to show you that it's easy to separate nav entry creation for different features or modules. Okay, so that solves how we can modularize the content for each of our screens into feature modules, but it doesn't solve how we can navigate from one feature to another. Let's imagine we have a future version of the app where our chat screen might want to navigate to a profile screen, and the profile screen might want to have a Start Chat button which opens the chat screen. This requires two feature modules, Chat and Profile, and these modules need to navigate to one another. So how can we implement this? Well, we can't have the feature modules depend directly on each other, as this would create a circular dependency. Okay, so how about we hoist the navigation events into the app module? The feature modules expose parameters, such as onProfile clicked here, and the app module supplies the lambda to be run. This is possible, but the problem is that it gives a lot of responsibility to the app module for wiring everything up. It also means that the app module will need to be updated every time one of the feature module's navigation events change. You can see from the code example here, the chat list screen already knows that it needs to navigate to the profile module because it has an event named onProfileClicked. So why should it need the app module to implement it? I'd like to suggest an alternative approach. If navigating is as easy as pushing a key onto the backstack, then all we need to do is ensure that each feature module has access to the keys it needs to navigate to. Of course, the problem is, how does the chat module get access to the profile navigation key without depending on the profile module? So this recommendation should be familiar to some of you who've already worked on multi-module projects. You can create two submodules for each feature, an API module and an implementation module. The public classes, including the navigation keys you want to expose for each screen, go into the API module, and the content for that module goes into the implementation module. This structure means that one feature's implementation module can depend on the other feature's API module for the screens that they need to navigate to. And this is all without creating circular dependencies. So let's see this in practice. The first step towards our more scalable solution is to switch to using the entryProvider DSL. So I'm just going to comment out our when statement here and call entryProvider to give us access to this DSL. Now what we can do is we can call entry for each one of our screens. We give it the type, so we'll give this one chat list, and then the trailing lambda is our content. So we can just copy the content from our previous when statement. We'll do the exact same thing for chat detail and copy the content from before. And entry's trailing lambda gives us access to this key so that we can access any navigation arguments. We can get rid of our old code. And now, hopefully you'll agree, this is a lot simpler and easier to read. So now that we've refactored our code to use the entryProvider DSL, we can now move each entry into an extension function. So I'll do this using Android Studio's extract function so that we can move each one of these entries into its own function. So I'll call this chat list entry, and I'll do the same for the chat detail and call this chat detail entry. So now that we've got our extension functions for the content and we've got our keys declared up here, we can start refactoring to modularize this code. We'll take the keys and move them into the module structure that I already talked about. In our chat API module, we'll just move those keys, and the content will go into our implementation module. I need to change the visibility of each of these extension functions because they need to be accessed by other modules. And I'll just fix the imports as well. So back to our main activity, we now need to import these functions and import the key for our starting screen. Okay, so we've modularized this code, and this should make our feature teams happy because they have complete control over their content and their keys. So now let's add a new feature. So we talked about this profile feature where when you tap on someone's profile image, we want a new screen to appear, which gives us information about that person's details. So I already have this screen ready to go, and this is done in the exact same way with profile entry. All we need to do is hook up the navigation event from the chat detail screen to profile entry. So to navigate, remember, we just need to add a key to our backstack. So our chat detail screen first needs access to the backstack. So I'll use Android Studio's fix method here to ensure that our detail entry has access to this backstack. Now our content has an event lambda called onProfileClicked, which gives us the profile ID of the person that we've just clicked. And now we just need to create the profile key. You'll notice this comes from the API module inside the profile feature, and we can specify the profile ID when creating this key. So let's run the app now and ensure that everything works. What we should see is that when we tap on the profile image, a new screen appears with that person's details. Okay, so looking at our main activity here, we can see that every screen has its own extension function. And in apps with a lot of screens, this could become a very long list. And this is normally where you would reach for dependency injection. And we actually have a recipes repository that shows you how to use dependency injection to inject all of these different entries in a more scalable way. And I'll share that at the end. So now we have 3 screens in our app. Let's see how we can customize the animation between those screens. We figured you'd want to be able to override the screen transitions globally for all screens. So this is done by the NavDisplay UI component. And we also figured that you'd want to override the screen transitions for a single screen as well. So this is done at the NavEntry level. Let me show you this in code. So NavDisplay has some transition spec parameters. And these allow us to specify the transition between screens. So I really like the kind of slide animations that allow screens to slide in from one direction and slide back out the other direction. So I'm going to have a slide left transition for all of my screens when we navigate to them. So I'll just fix the imports here. Okay, and the thing about navigation is it's directional. So we can navigate forward to something and we can navigate back from that thing. And we need different animations for each direction of travel. Now, this is why NavDisplay offers other transition specs for when we go backwards. So we have a pop transition for when the user taps the back button. And we also have a predictive pop transition spec for the predictive back animation. And I'm going to use the same one for each one. So slide right, which is going to slide the content out to the right. Now, the transition specs that I'm using here are all from the Animated Content API. So if you're familiar with that, you can use the exact same transitions in transitions for NavDisplay. So if we run the app now, we should see that we have slide animations between the screens. So here we go. It's quite difficult to see on the emulator, but if I do the predictive back, you should be able to see we can slide really nicely between these screens. So that's how you override the animations at a global level. Let's look at now how we can override at an individual screen level. So for our profile screen, what I'd like, because it kind of feels a bit different, is for it to slide up from the bottom. So to customize at the profile entry level, we can use something called metadata. And metadata is just a map of additional information you can attach to your nav entry. The nav display can read this map and then changes how it animates that particular nav entry. So I use the metadata parameter, and then nav display gives me a helper function called transition spec that allows me to override that global transition for all the screens. So we'll do slide up for this one. Now metadata, because it's just a map, we can append new map values to each piece of metadata. So we'll do the same thing, but this time using the other helper methods for the other transitions. So when we go back from the screen, we're going to slide down. And the last one to override is the one for predictive back, which is the predictive pop transition spec. So we'll do slide down for that as well. Now, when we run the app this time, what we should see is the profile screen slide up from the bottom and then slide back down again when we go back from it. And you'll see here that we can use that nice predictive back to see the screen behind the profile screen. Okay, so this is all great. And I'm not normally the one to point out problems in my own code because I want an easy life. But if we hit the unfold button on this emulator, you'll see that our app doesn't look the best. it doesn't adapt to the available window width. And this is usually where you'd reach for a list detail layout, but that can require some big architectural and UI changes, and it can also introduce its own navigation challenges. Luckily, using NavEntry, we're able to add multi-pane layouts in just a few lines of code, thanks to a concept called scenes. We know that phones are still the #1 priority when it comes to form factors. It's common to start with a phone app and progressively enhance it by focusing on the user flows that give you the biggest return on larger screens. This is why NavEntry's Nav display is designed to provide the best phone experience out of the box. It displays one entry at a time and supports the full transition animations you'd expect, including system back. Our goal is that whatever you layer on top, this default will serve as a solid foundation for the majority of your users. Where it gets interesting is how we do that layering, which is via a concept called scenes. So under the hood of Nav display, a scene controls how entries are displayed. Its default behavior is just to render the last entry in the backstack in a single pane scene. But scenes can contain more than one backstack entry. Imagine your app is running on a foldable device, and when it's unfolded, you want to render two nav entries side by side. You could create a two-pane scene that does this. Scenes allow you to define different layouts for different scenarios. So you can define scenes for showing a dialogue, a side-by-side list detail, a horizontal pager, or really any other layout that you need. But how does Nav display pick the correct scene to show the entries? This is done using scene strategies. A scene strategy essentially asks one question. Can I build a scene? If it can, it returns it. If it can't, it returns null. The Nav display can receive an ordered list of scene strategies using the then infix operator, and each one will be evaluated in turn. If the first strategy can return a scene, then that's the one that's rendered. If not, it moves to the next strategy and does the same thing. If none of the supplied scene strategies can create a scene, then Nav display always falls back to the single pane scene strategy, and the last backstack entry will be rendered in a single pane scene. The nice thing about this API is that anyone can create scenes and scene strategies to support different layouts and different device configurations. So let's take a look at an example for list detail. This strategy's logic is twofold. First, it checks the window width to see whether it's large enough for a list detail layout to make sense. Second, it checks to see whether the entries in the backstack have opted in to being displayed in a list detail layout. That same metadata that allowed us to set custom transitions for each entry is also used to define the role that nav entries play in the list detail scene. Let's look at this in practice. So we'll go into our main activity here, and the first thing we need to do is define a strategy. And I already have a strategy defined for list detail, and I can create that using remember list detail scene strategy and just give it the type of the elements in our backstack. To supply that strategy to our nav display, we use the scene strategy parameter. And that's going to ensure that that strategy is evaluated each time nav display is recomposed. Now we need to mark up our content to tell it what role it would play in the list detail scene. So for our chat list entry, we can specify metadata, and the metadata value is provided by our list detail scene strategy. So we just say list pane, and we're going to do the exact same thing for the detail entry, except that we call detail pane. So now let's run the app, and hopefully we will see that when we unfold our foldable, our list and detail screens are displayed side by side in a list detail layout. This approach allows each feature team to progressively enhance their own module for large screens without any activity changes besides adding the scene strategy. So we've covered a lot today, from the very basics of NavEntry to modularizing our navigation code, adding animations, and adapting our app to support larger window sizes. But that's really only scratching the surface of what NavEntry can do. We didn't even touch on nested navigation, dialogues, bottom sheets, or scoping view models to nav entries. To explore these cases and many more, check out the recipes repository and our official docs. Thanks for watching.